Yeah. Alright, so tonight I'm going to talk quite broadly about configuration management development principles, but I'll be referring to Ansible for examples and kind of case studies. So I've put this presentation, it's up on GitHub pages, there's a link there. There's code samples in the same repository under an examples directory. To save you having to remember all that, I've put it on my GitHub pages, which is willthames.github.io. So, who am I? I'm Will Thames. I build the future. If you don't get the reference, check out any of Andrew Schaffer's recent presentations. I've been with Suncorp for 18 months. I do kind of systems engineering, delivery solutions. Before that, I was at Betfair in the UK for 8 years. So I've got a lot of experience with big enterprises, administering thousands of machines, running hundreds of different applications. At Betfair, we use Chef. So from where we brought that into where we got to see what mistakes you can make and how to do it right. Let's say my talk's about Ansible. So Ansible's been around for about 18 months now. The first commit was made in February last year. What's nice about Ansible is that it's daemonless, meaning you don't have to install an agent on the server. It runs over SSH. It uses your existing privileges to log in, which means that all the privileges that you have as a user, you can do things with Ansible. This means that system administrators who like to restrict their boxes are quite happy that you're using Ansible rather than, say, Chef or Puppet, because they don't have to give you any additional privileges to those you already have. Another thing that makes it nice and easy is that it requires Python rather than Ruby. Python's installed by default on a lot of Linux systems. For example, Ruby is typically a bunch of extra things, extra moving parts. Ansible's recently kind of formed a corporation called Ansible Works. They recently raised $6 million venture capital, and that's driving their business, and they're offering enterprise solutions. But the core of it it's all open source. You can submit pull requests on GitHub. You can submit issues. It's easy to contribute. I've done it. So. One of the things that makes it a bit different to, say, Chef and Puppet is that it assumes a homogeneous environment. So rather than say, I want to install this package, you have to say, I want to install this RPM using the Yum provider, or this dev using the apt-get provider. And that's entirely realistic in most corporations. Most corporations tend to run one or two operating systems. They don't tend to have a bunch of Ubuntu servers and a bunch of Sentinel servers that typically stick to one stack. But what it does discourage is reuse between different corporations, where you can write a playbook that says deploy Apache to this system, and it just deploys Apache. You have to be a lot more careful about exactly what you're doing and how it applies to the particular operating system you're depending on. So there's less abstraction, but it means it's a lot. One thing it's typically a lot easier to get started with. And it's task-driven rather than convergence-driven. So Puppet you tend to say, right, I want a system that has these things and looks a bit like this, and Puppet does a load of stuff, and eventually it all converges, and it's the system that you've declared it to be. I'd say that Ansible is less declarative than Chef, and much less so than Puppet. So in my demo, I've used Vagrant to knock up a couple of virtual machines. The interesting thing is that Vagrant now supports Ansible as a provisioning method, which is cool. You basically say, right, take this Vagrant box, and at the end run this Ansible playbook, and it does all the additional things. And this is the Vagrant file that I've pretty much used for this presentation. So I've to find a box that runs a server that acts as a shop, and a box that runs as an account management system. And at the end of, after Vagrant's created them, it will then provision them using Ansible. And the Ansible playbook that I wrote for this demo basically put an extra host in and ensure that I can write to a directory so that demos work. And this gets run as root at the end of the provisioning stage. So, how do you get started with Ansible? Ansible typically is typically packaged, so you can get it from yum or apt-get. That would typically be a few versions, probably a few point releases, very minor releases behind. I tend to live at the edge with Ansible, just because typically it all works fine, and if it's not all working fine, then I like to find out why. So I found a few bugs that would have hit us sooner or later by always living at the edge. So you can clone it from GitHub, install a couple of Python modules, create a setup, and this is pretty much all you need to set up Ansible. So you have an inventory file which describes the hosts that you want to manage, and you tell it where the Python libraries are. And then all you need to do is talk to your target hosts, generate an SSH key if you don't already have one, make sure that it's added to your agent, and then use SSH copy ID or some other equivalent to put the key onto your target regime. And there is a running Ansible command. Basically, this is using Ansible rather than Ansible playbook. Ansible is kind of a tool for just running ad hoc commands. So here I'm just saying, hey, what's the date on this server? So it's pretty easy. Just say, right, the modules command, the argument's date, and I want to run on the web host. So, this presentation is mostly about Ansible, but the principles within it are applicable to Chef, Puppet, Salt, CF Engine. I don't really want to get dogmatic about what configuration management framework is best. Using one is better than using none. So this is my example environment that I'm going to refer to in this talk, just to give it a bit of context. So we're going to say, right, there's a shop and there's an accounting system, and we've got a dev environment with a couple of servers and a couple of databases, and we've got a production environment with twice as many of those things. I should refer back to that. So what are the naive approaches to managing that kind of environment? Obviously there's the Snowflake server approach, where basically you log in by hand and set everything up in a nice way, and every time you want to make a change to it, someone logs into it and runs some commands, and that all gets really nasty quite quickly. And then there's kind of SSH and a for loop, running a bash script on each server. And that's slightly better, but especially if the bash script is actually checked into version control. But it's still problematic. Typically bash scripts aren't very good at doing the same thing twice. So if it adds a user or adds a group, or I don't know, there's plenty of things that you can only do them once, and the bash script will fail in a big fire if it's if you try and do such tasks. Another way that commonly used is each configuration has its configuration checked into version control. Again, that works, but if you've got 100 servers and you want to change the Java version on all of them, that's 100 files that you've got to edit and make sure that they're committed back into source control. None of them are particularly nice. So, configuration management to the rescue. So I'll kick into demo mode here. So this is kind of my most naive approach to configuration management, where basically you kind of list a load of tasks in order. So I want to get Java, and then I want to install it, I want to download Tomcat, and then I want to install it, and I want to install the app, and make sure log shipping is working correctly, then I'll start Tomcat up. So that's the accounting server, and the shop server, and they look pretty similar. So basically, I've just copied and pasted the accounting playbook onto the shop one and changed some of the things. So it does slightly different things, but there's a lot of commonality. So if I run my playbooks against my hosts, so this is basically running the simple shop playbook against the shop, and it will run through these things. It's done it. I've already run it before, so it's not changing very much, which makes it nice and quick. But basically, it's running through each task in turn, seeing whether the configuration it's trying to get to is there. If it's already like it how it wants to be, it does nothing. It just says OK. If it changes something, it says change. And it can run handlers. So you can say to a task once you've finished, at the very end, kick off this job. So it's very task-driven, lots of steps in sequence. But already we're seeing some of the benefits of configuration management where it's idempotent, so you run it twice and nothing really changes. So that's a bit of a demo. I'll come back to the demo in a minute. So what can we improve? There's an awful lot of copy and paste there. There's an awful lot of commonality between those two playbooks. So we can think about refactoring that, making it more modular, making the configuration more hierarchical, ensure we've got decent repeatability and some security. In terms of modularity, pretty much all the configuration management frameworks have some way of saying, right, when I'm doing this set of tasks, I want to use this blob of configuration followed by this blob of configuration. So I don't know, rather than saying I want to download Java, install Java, make sure that the symlinks are correct for Java, you just say run the Java playbook. And then I want to run the deploy my application playbook. And I want to run the setup log shipping playbook. Ansible also recently introduced role dependencies, so that rather than just saying, as well as saying for this playbook I want to have these roles, you can also say, well, this role depends on this other role, and you can kind of break it up into nice, small, modular parts. And it means that kind of simple tasks that you might want to run on lots of different kinds of services, so log shipping, installing Java, they're typically going to run on lots of things, but be configured completely differently, and you can abstract some of that out. Hierarchical configuration. Configuration is typically multi-dimensional, so there's stuff that's specific to the environment in which an application lives. So there's a lot of things that are common in a dev environment, and then there's different things that will be common in prod environments, and also application specific, so that things that are common to, so the dev version of an application will have things in common with the prod version of that application. And also you might have different groups of environments, so you might say that all the dev environments should look like this, and all the prod environments should have these properties set. So you kind of want some layers where you kind of go from the specifics of a particular host, and then running a particular application in a particular environment, and go up the stack until you might have a load of default values that you set for all your services. So going back to my example, there's going to be things that are common in dev environments, such as mail gateways and log shipping destinations and log levels. And there's going to be things that are common to applications, such as the files you want to log ship and JVM versions. In terms of repeatability, so I think there's two key elements to repeatability. Invariance, running the same playbook should have the same result, no matter how far apart you run them. And that means that you should make sure you refer to a very specific kind of tag or commit when you're checking out from version control. You should say you want to install a particular version of an application package. And then there's idempotency, where running in the same playbook twice should have no additional effects. So So you need to check that, if you're adding lines to a config file, that you're not adding it again when it runs again. And as I said before, most of the configuration frameworks handle that just fine without very much additional work. Some things, if you're kind of execing out to a command, you might want to check that, if you're extracting something, that it doesn't overwrite some stuff that's already there. But it's a lot easier to do under the framework than in a bash script. And version control is not just for application code. So it should be obvious that you should look after your playbooks and your attribute files and your roles in source control. But you also need to make sure that your version of your playbooks is well managed too, so that if you're improving a playbook so you can make some changes to the dev environment, you've still got your old production playbook ready to go in case you need to do a rapid fix in production or something. So you need to manage your source control for playbooks just as well for configuration code as application development code. So lots of ways to achieve it. One way is cheap branching using distributed version control system, so you can have different branches for your different environments or different kind of releases of a playbook. But that's just one way. There's many ways to do it. So security. So there's a few things that you don't want to happen. You really don't want your production database passwords kind of stored in GitHub in a public repository, or even in a private repository, or even really in your private source control on your private servers. You don't want your Amazon private keys in source control. If they are in source controls, they should be encrypted. And so there's solutions to this for Chef. Chef has encrypted data bags. Puppet has, I think, PG applied to keys. Ansible Vault seems to be in the works. I asked the guy who kind of came up with the idea the other day if it's still a work in progress, and it seems to be getting there. It just needs a bit more traction. But there are ways to make sure that you encrypt and decrypt your sensitive data before it gets written. So I'm going to quickly go back to source because everyone likes to see source code. So I refactored the simple playbooks that were first cut, and I kind of just took some of the variables, extracted some of the variables out. But it's still pretty similar. We just get rid of a bit of rather than stating everything explicitly, we use variables, and these variables can be associated with hosts rather than stored in the playbook itself. So you can say, right, for the shop I want Java 17021, and for the web I want 17025. And that's pretty much where I get to in the very minimal version, where here I just say, right, I want to install Java, I want to install Tomcat, I want to install some log shipping stuff. And if I and the way that's achieved is through. So here I just set up. So for the shop server, I set for any shop service, I set these variables up, and this allows the shop to be different from the accounting system. But basically, the roles, the kind of task files in the roles take these values and use them to configure the target. So you can basically abstract a lot of the information out and just treat the minor variations between environments as variables that get applied when processing configuration of code. And this one basically runs in the same way. And the structure of this is that it has three roles under the configuration directory, so that there's a Java role, a Tomcat role, and a log shipping role. But it's all still doing the same stuff, in the same order. It's just a lot easier to kind of see it at a glance, and then so the rest the playbook is saying, right, install Java, then Tomcat, then Logship it, and then you can look at what the actual Java role does and how it's configured. So software development practices. Everyone knows you should test your code. So Chef has Chef Cucumber, Puppet has Aspect Puppet. There's not a common framework yet available for Ansible as far as I'm aware, but you can still apply similar principles, which is basically do things with dev VMs, build them up, knock them down, rerun playbooks, and often the application testing you do will pretty much test that things are working as you expected anyway. For static analysis, Puppet has Puppet Lint, Chef has Food Critic, and as of this week, there's now Ansible Lint. And I've just wrote a pretty extensible linter for Ansible that kind of runs against some playbooks and says, hey, this isn't particularly good behaviour, you should think about doing this slightly differently. So that's on GitHub, and you can contribute to that if you wish. At the moment, it checks for things like executing out to shell when you could be using an Ansible module. It checks that your brackets are sensible. It checks for repeatability, so that you've set a version of, you've set a commit to check out. What about the DevOps? So really, developers should be working with operations on playbooks, so the playbooks can work in all the environments from dev through to production. Shared ownership of playbooks is ideal. In almost every organisation, there's going to be some boundary somewhere, except the very smallest, where the system administrators are going to want to control the system bit of the stack, and you're going to want to, and the application owners are going to want to control the application bit of the stack, and there's going to be a boundary in the middle that will be specific to most environments. But you can have things where operations provide playbooks that set up and configure monitoring and log shipping, and then when you're setting up your developments, new environments for development, you kind of say, right, well, for log shipping, you guys have written this log shipping playbook. I want to have these logs shipped in these directories, and I want them shipped over there. And the variables that you set as part of your the configuration of your development system, your application rather, will be used when running that playbook. So you can kind of have shared ownerships without treading on each other's feet. In a very pure DevOps environment, it's probably not a worry. You might have one guy who's just developing and operations, but in most organisations with more than a few developers and different people doing operations, there's going to be some boundaries somewhere. Okay, that's definitely relaxing. So, Ansible, where can it be improved? It could do with a testing framework. It could do with something to manage sensitive data. It'd be nice if there were community playbooks. There might be a few, but they're not well known. Chef's got the Chef cookbooks, GitHub repository. Puppet's got Puppet Forge. I haven't really seen the same thing come out for Ansible, and whether it's because, referring back to some of the things I said earlier, that people are kind of writing the playbooks to their specific environment. But things might improve, and it's a worthy goal for people to at least think about. And where does Ansible excel? Well, it's really easy to get going. You've basically got to kind of install a bit of software, set up some keys, and that's how you get going. How you write a decent configuration management system for your entire environment is probably quite a hard problem, but it's really easy to get started. Ansible's really good for orchestration. So when we had Chef in our last place, Chef was great, but we then had to think, well, how do we tell servers to update their Chef configuration? And I think we ended up using Func, but Func's not particularly easy to get going with. It's hard to write it's hard to kind of automate just finally say, I want to do this, then this, then this. Ansible's great. You can just say, hey, run Chef client across these boxes here. And because it has inventories which are hierarchical, you can say, right, these hosts live in this group and these hosts live in this group. You can just say, right, I just want to run it on all the odd number servers. And that'll, assume you've got a group called odd number servers. It's really fast moving, which sounds, doesn't necessarily sound ideal, but in practice, have been very few backward compatibility changes. The API, the Ansible playbooks themselves, one from a year ago would probably still run now. They have tried really hard to make sure that they're backward compatible. So people are contributing modules all the time. People are improving the actual kind of core system of how it operates. So roles were only introduced a few months ago, and role dependencies were kind of I think they get released public, the actual public release kind of tomorrow or something. So they're all really, so improvements happening all the time. So I've put up some useful links at the end. So where to find Ansible, Vagrant, Ansible Lin. There's a great talk at PuppetConf last weekend on refactoring Puppet, and a lot of the similar points were made there. And I wrote the slides using Real.js, which is handy. Cool. And any questions?
You're using Chef previously. How did you end up on Ansible?
Well, if you've got system administrators who are willing to give you complete access to your system, then Chef's okay. But
starting from that.
Yeah, so you start from I haven't got Ruby and I haven't got root access.
Yeah.
Ansible's a realistic solution in that kind of environment, but having said that, it's got a lot of things that one of the quotes I think on Ansible's website was it took me a day to work out how to do it in Ansible. Well, I've spent 2 weeks trying to work out in Puppet, so it is pretty simple and easy to get started with. And with there's trade-offs to be made. In a massive environment, you might be better off using Chef. You might be better off using Puppet, but it's definitely worth considering Ansible.
Did you try Fabric or Salt?
No. I think Salt and Ansible kind of appeared at the same time, and I'd already kind of invested a bit of time in looking at Ansible. Most of the thing about Ansible is it runs over SSH, which is great. I think Salt runs over 0MQ, so that's kind of a bit of a hurdle. I'm not sure about Fabric. I haven't really spent much time looking at it.
Pretty simple. Bit Python runs over SSH.
So you've got a situation where there's some instability in some of the fleet of VMs. Do you use Ansible to deploy resets or monitoring or investigations?
I think it's probably more appropriate for. I mean, you can certainly kind of send it commands and it sends you data back. You can kind of send it commands and it will do stuff. But whether it kind of would really depend on the situation and whether I'd be worried about that kind of thing making things worse. But last year's leap second bug with Debian, where you had kind of system administrators having to suddenly do stuff to thousands of servers, it would have been ideal,
But preferably you want a stable, known environment that you're issuing these things to.
Yeah.
But what about performance? Have you used it at any sort of scale to get a feel for how?
I haven't used it at much scale, no, but they have done a lot of thought into that. So one of the things so I tend to just use SSH for connections, but one of the things they do offer is what they call Fireball, where basically it kind of creates an ephemeral 0MQ at the other end, and then then it can just use that 0MQ for kind of orchestration for the next couple of hours, and then just disappears. And apparently that's super fast. So I haven't got to the point where I needed to worry about it, but if I had to kind of do stuff on thousands of environments and thousands of servers, then probably might want to think about Fireball.
I noticed at the start it's gathering facts.
Yes.
Have you compared that to how Puppet and Chef You know,
Well, Ansible can run OHI and it can run Factor,
Right.
so they're both modules that are included in Ansible. I haven't done any kind of real comparisons. Every time I've kind of wanted to get a fact, it's pretty much been there.
Yep.
And I think writing your own kind of Factor plugin is like utterly trivial. You basically kind of deploy a script that kind of prints the thing out you want in JSON or
Yeah, in
Sure.
JSON, it produces JSON, you can access it back.
so yeah, it's very extensible.
So you mentioned like the environment you're using it in now, like it's hard to get approved and everything. I'm interested, do you see it as like a replacement for Puppet and Chef, or more as a, like, do you, like just in your personal experience, do you use the orchestration part more to just say, oh, I need to do these tasks, rather than that, as you said, like it's not that great at the convergence idea, which is I want this system to always maintain in this state? Like, do you think it's, like, I'm trying to, because I've used Puppet, I actually use Ansible, and I'm still trying to reconcile that in my mind if I want to turn off Puppet completely and just go with Ansible for that reason. It's kind of like, I love the orchestration of Ansible, but
Yeah.
I'm not sure if I really can see it taking the place.
Yeah, I'm not sure. I mean, I think if I had lots of choice, it would be a lot harder. It's like, you know, I mean, I've got a lot more experience with Chef than anything else, and you know, I find the way that, you know, Chef recipes work and how, you know, writing new providers and all that stuff, it's all just kind of Ruby. You know, that's quite easy from a kind of development point of view, and you know, it makes it nice and easy to be modular, and you know, there's lots of people writing providers and resources, and the Chef community is brilliant. So if you know, it's kind of hard to know, you know, which the best approach would be. I think it really does depend on the needs of your particular environment. I think if I had lots of stuff already in Puppet, I'd probably stay in Puppet. If I had lots of stuff already in Chef, I'd stay in Chef. If I was starting from nothing, I think it would depend where I wanted to be. I think Chef and Puppet are really hard to kind of get started with, but once you've got a massive, you know, they're great for massive environments.
it sounds like a good tool to kind of like have a quick win. You know, like if a team had never used anything,
Yeah. Oh yeah,
like
definitely.
you could probably get them to understand it really quickly. Whereas if you've got someone who kind of is still a bit ambivalent about the whole concept, and then they've got to like understand Chef or Puppet, and they've already probably hate Ruby, you know, that's kind of like a gateway drug.
Yeah. The way I've found myself using Ansible recently is it's also, you know, if I'm doing a kind of, I don't know, setting up a new system, and you know, say I'm doing an upgrade of some product that's already in, that we've already got, but it's got kind of a bit of documentation but not much, and you know, I do the upgrade in dev. If I want to hand that over so someone else can do it in prod, I either write a load of documentation that says you need to edit this file and set this value, or you just write an Ansible playbook that does it all for you, and then you can say, hey, just, you know, this is the documentation of the upgrade, and that's really nice. And it is so easy to just write, because it is just do this step, then do this step, then do this step, and you know, hopefully not, you know, using shell commands, but you know, the understanding how the kind of declarative stuff works with like file and copy and stuff it's all pretty straightforward, and the documentation's pretty reasonable. Certainly the other day I was looking at the Chef documentation, just trying to work out how I would do a certain thing, and it's just like, okay, unless you already understand Chef, you've almost got no chance. So yeah, that in itself makes Ansible quite easy to use.
Well, coming from that same paradigm, you're doing iterative upgrades. Say you need to redeploy to the latest version. What are you going to do with Ansible? You're just going to run the upgrades all the way from day zero all the way through to get to the latest version, or can you try and tell us just?
I think it depends how you're doing it. I mean, a lot of there's enough upgrades that where you kind of unless you're certain that they're definitely going to work, and that's rarely the case, then you're typically going to be backing up your old system somewhere and making sure that it's still available to roll back to.
Say you actually deploy a new node to expand outwards or something.
Yeah, I mean, I'd be writing them to kind of say get to that point, but I think you'd have a setup. The last, when I was doing a Confluence upgrade recently, I just wrote an upgrade playbook. But I think if I start from scratch, I'd write a setup playbook that always just worked. But you do need to be careful that you kind of don't just blow away stuff that you actually really needed. That's what testing's for.
Cool. All right, thanks, Will.
Just one more question. Is there any kind of dashboard that takes the data that 1,000 machines out there, and this is 500's got this version, and this 250's got that version, and
no,
Yeah.
but I think that it's only free for 10 machines, and it's
Yeah,
like
it's
$250
but
a
it's
node a
Ansible
year.
works products there.
Yeah, but the API is really good, so it'd be pretty easy to write your own.
Yeah.
So yeah, I think the way that Ansible, it's going to be something to kind of bear in mind, that they have just created a corporation, and the stuff that might be quite nice might get kind of pushed behind.
Because I have 1,000 machines under my control. I wouldn't upgrade all 1,000 to the latest version of Postgres or whatever it was that I was upgrading. At the same time, I'd upgrade, a quarter at a time.
Yeah, but I mean, it's quite easy to just say, right, just upgrade this quarter,
But then
then
you can
upgrade this
actually,
quarter.
if you do it over, you can show people the progress with
Yeah,
a dashboard.
but I mean, it's written in Python. It's pretty simple.
Yeah.
Coding against the Python API is very straightforward. Kind of depends how much money you've got and whether it's cheaper to develop, to just kind of write your own kind of views on it, or pay Ansible Works a chunk of money. It's free for 10 machines though.
So the machine that Ansible's running from needs to know about all the other nodes that...
Yeah, Ansible has a concept of an inventory, which can be a text file that just says, right, there's all these files and they're in this group, and these nodes are in this group. But it also, you can just set the inventory to be the result of a script, and that could just get stuff out of DB, or it could be the results of Hira, or there's plenty of ways. Yeah, it's quite easy to kind of have the inventory be dynamic. So it does make it quite easy to tie to whatever source of truth you want to work with.
Did you really call your cats DevOps?
That'd be pretty cool though, wouldn't it? Yeah, don't think my wife about that. Cool. I don't know, maybe she'd like it.
Awesome. All right. Well, thanks, Will. Listen, Pete's is here, and we're just going to coalesce sort of just outside. There's a couple of tables outside.